We are in lesson 7-9.
Wait,
Daisy, you are smart. And you're going to go to an amazing college, and I'm going to miss you. I'm going to miss you too, Rochelle. And you are also super smart. You are in AP Calc. I'm going to miss both of you too. Today's date is Tuesday, March 19th. March 19th, 2019. Are the lights okay? All right. So we need to discuss every single formula that we have. We have a lot of formulas. See if we can remember all of them. And it has been like a week since we've done a lesson because of all of the college stuff that we've been doing, and ski, PE, and all of the fun stuff. So sequences, arithmetic sequences. If I want to find the nth value of that arithmetic sequence, what's the formula? We'll say a of n is equal to, see if anyone can remember it.
For a sequence?
For a sequence, yeah.
It's going to equal n. 1.
So it's the first term. How do I say the first term?
Oh, A1.
A of 1. And then I add on.
Plus A2.
You keep adding A2, A3, A3, yes, or A4. But what's the formula to find the nth value?
A n minus 1.
There it is. So it's something times n minus 1. What is that something?
R.
It's R for geometric series. This one is going to be called...
Common difference?
It is the common difference. What letter should we use? Common ratio, common difference. This one is R. This one should be...
D.
D, yeah. So common difference, D. And then you can make that note that this D right here, this guy is the common difference. I'll just say diff. All right. Very, very similar to arithmetic sequence. Let's talk about a geometric sequence. So I'm in the top right now. I'm going to say G of n is equal to, very, very similar. What do we have? I have to
It's
say,
going to be A
well, we'll say G, right?
G minus
Ooh, careful. So we have to say the first term.
G1
G of 1, yep.
minus.
So instead of,
No. G of 1 to the power of n minus 1.
you're so close. Ugh.
Is it plus R?
So there's some R in there.
Multiply?
It is multiply, yeah. Multiply instead of add. R instead of D, because R represents the common ratio. This guy right here is the common application, just kidding, common ratio. College joke out there for people applying with the common application. To the power of n minus 1, as Rochelle told us. All right, cool. So now we know sequences. That's a good little review. What about for series? You guys remember adding up all of the arithmetic sequence? Adding them up, turning it into a series? Do you remember the general procedure? The story of that guy up there, number 3 on my wall? Or it's not Leibniz, it's, what's that? Carl Friedrich Gauss, right? When he was in elementary school, what did he do?
He made a formula.
He made a formula. Well, he discovered the formula in his head. A bunch of people had found it before him, but he's the famous example that we always use. What was his formula? I'm going to say A sub S. So A sub S, because I'm summing. A sub S of n. I'm just going to do a subscript, so I do a little s, because I'm summing them.
A minus A, right?
Ooh, I think you're thinking of a geometric series. You're doing a good job, Rochelle. Keep it up. All right, remember the general idea? Don't write any of this down. He did the first plus the last, second plus the second to last, third plus the third to last, fourth plus the fourth to
The
last.
rainbow.
The rainbow. That was Carl Friedrich Gauss. When he did the rainbow, he added the first plus the last, and each of those added up to the same number. And then from there, he counted the number of pairs and multiplied the adding of the rainbow, so whatever the rainbow added to, and he multiplied it by however many pairs there were. So does that help you remember what the formula was?
No.
No? So what did he first do to do the rainbow? First plus last. How do I say that?
So it's, oh, okay, I remember. So it's last plus 8 start.
Yeah, we can just say start plus last, because we know that start is A of 1, last is A of n.
So A of n minus 1.
So if we want to, yeah, we can either say first plus last, or we can say first like this, plus last like this, a of
Wait, okay.
n. It's not n minus 1. N is the last. N minus 1 is the second last.
Over 2.
So I'm going to write up here, this was the first term plus the last, I don't know what I'm spelling, last term. And then, so that represented a rainbow. And then he multiplied that rainbow by what?
R. I mean D.
Not quite. So if there are n terms, that means there are how many pairs? N divided by,
2.
yep, so we multiplied all this times n minus 2. And this represents the pairs. How many pairs do you have? You have n divided by 2 of them. This was the pairs.
It would still work either way if you put divided by 2 to the other side, wouldn't it?
Exactly, yep. I wrote it like this so that we can remember it better because we know the story of the rainbows and multiplying by pairs. But both ways work. I could have written the divide by 2 over here if I wanted, instead of on the right. All right, from there, we did our geometric series, which was our last lesson, 7-8. So I'm going to do G sub S of n to say I'm summing up all of these numbers. How do we do that? This was a long proof that was kind of difficult, but the proof ended up and it spit out a formula that said, I guess it's technically, oh, these should have S's, sub S, I forgot those. Because if our thing has an S out here, these should also have S's there. All right. What was our formula over here?
GS
Of
1.
Yep, so the first term, GS of 1, and in our formula before we called that A. Sometimes this is just called A. So I'll put an A up above that. But that just means the first term. So the first term, then what do I do? That's going to be times,
Not times. No, because it's A minus AR.
I factored out an A. So we don't have to keep writing GS of 1. All this times 1
N by the power.
1 minus
1 minus R.
to the power of
Oh, power of N.
power of n. Is it n or n minus 1?
I think it's N.
It is n. Yep. And then all of that divided by
1 minus R.
1 minus r. Where r, again, is the common ratio. So I can have another arrow coming here. Common ratio. And again, a is another term for this, but it's also the first term. So I'll label that as first as well.
Is it 1 minus R divided by the whole thing?
Yes. I mean, it's the same thing as saying this. I could have written this, drawn this line a little bit farther. Both are the same thing mathematically. Whew, all right. And so those are all the formulas. To find the number of terms, there's also a formula that you have to remember. Do you remember it? Last minus first, all that stuff.
Plus 1.
Mm-hmm. So, and I guess it depends if you're in arithmetic or geometric land. So maybe I should have continued the table down like this. But it's usually the last minus first divided by d plus 1. And this one is going to be last. Ooh, this one is going to be tricky. I don't know if we've seen this formula before. And I have to rederive it right now in my head. Let's leave this blank until Mr. Sindel can remember it. It's something with division and, again, adding 1. I'm pretty sure it's going to be like last divided by first divided. I don't know. It's going to be. I'll figure it out later.
Just without dividing D
I think it's a little bit more complex because, okay, let's derive it right now. This is how Mr. Sindel thinks. So the general idea is I start here, A, and then I multiply by R, so I get A plus, or I'll do a sequence A, and then AR, and then AR squared, then AR, blah, 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 to the nth. So there's some dots in here. So how do you make sure that you count the number of sequences? Well, we don't know how many times we've multiplied by R. So we have to do AR to the n, and then we have to divide that because The reason that we're subtracting is because it's the opposite of addition. The reason that we're going to divide here is because it's the opposite of multiplication. So it's going to be divided by the first term. If I do that, and then we're trying to isolate n here. I think you have to take the log. Ugh. Okay, let's just ignore this for now. Let's do an example 1. All we're doing right now today is this bottom right-hand corner. Right, Daisy?
Yes.
Bottom right-hand corner, that's all we're doing today. We just needed to have those formulas memorized. All right, who wants to read?
Instead of dropping 2 hard spheres of different masses off the Leaning Tower of Pisa around 1890, what if
Galileo
dropped one bouncy sphere from the top of the 55-meter tower where the sphere registered 5/6 of the height of its previous bounce? When it hits the ground the 8th time, what is the total distance the ball has traveled round to the nearest 100?
Okay. So do you guys know the story of Galileo proving how gravity works?
I know Galileo from Bohemian Rhapsody.
Galileo.
Oh, that, yeah.
Yeah, so he was a physicist, mathematician, all of that stuff. Probably way more than that. He might have been an artist. I don't actually know that much about him, aside from the fact that he did this experiment in 1890. It was like 1888 to 1891. We're not exactly sure when it happened, and it's probably a myth that didn't happen. But the myth goes that Galileo went to the top of the Leaning Tower of Pisa, so you can think of a little stick figure Galileo right here at the top of the Leaning Tower of Pisa, and he had 2 balls of equal size. One was made of lead, one was made of, I don't know, styrofoam. One hard, one not so hard.
Probably made out of like a lead. It's perfect.
So they were different weights. The main thing is they're different weights but the same size. He drops them both.
Can we do that for like?
What happens? Do they hit at the same time? Does the heavier one hit first, or does the lighter one hit first? You have 3 options. Same time, lighter one first, heavier one first. What happens?
Heavy one, of course.
Everyone assumed that the heavy one
It's a trick question. It's a light one.
is actually both at the same time.
What?
Gravity affects all things equally, and that's what he was trying to prove by dropping those balls off of the tower. So if you actually talk to Mr. Brown, I'm sure you could actually recreate this in his physics classroom. But yeah, it doesn't really matter if I have hard versus, or not hard, but like dense versus not as dense.
Test it.
Oof.
Test it. I need something
Drop
roughly
it
the same.
here, and then I'm just kidding.
What are things that are not going to break?
Uh,
Are these 2 things roughly
the marker and
A pen.
something heavier? All I'm
Your
like
3D
looking at a
printer.
monitor, 3D printer, like remote control. All these things are going to break. What are things that are heavy that I can drop?
Then let's use a softball and those waffle balls.
We had
a softball on me. That would work.
balls.
Why don't we get one?
Here's a tiny little pencil and something obviously much heavier than a pencil. Yeah? So feel them. One definitely weighs more than the other. Do we agree?
Yes.
All right. Does Rochelle agree?
No. I'm just kidding.
They definitely weigh different things. So our theory is that the heavier thing would technically drop and hit the ground first. If I can actually release these at the same time, I'm a human, I'm not perfect. But I'm going to try to release these at the same time. We're assuming that this one would drop and hit the ground first. Ready? They hit at the same time. Ta-da! That's what Galileo did, but on a much grander scale. He went to the top of the Leaning Tower of Pisa. Probably not, it was a myth, but that's the theory. Good so far? You learned something new today? Gravity affects all things equally because gravity is just a force that acts.
Sucks. I'm just kidding. Why can't we just fly?
All right, so, but now instead of dropping those 2 balls of different masses, what he's going to do is he's going to drop a bouncy ball. Ooh, fun. He just got a bouncy ball from like, I don't know, some restaurant. He did 25 cents in the thing. He got a bouncy ball out. He's going to drop it. This is a super bouncy ball because every time it bounces, it comes back 5/6 of its height. Normal bouncy balls are like 1/10. Horrible bouncers. This is an amazing bouncy ball. It will come up to 5/6 of its previous bounce. So let's draw a mini picture. Do I have enough room here? It's going to be a quick picture, so use up only this much room because we're going to need all this other room for doing math. But think of the ball. So it bounces and hits the ground once. Then it might come straight back up, but let's, for the sake of...
It looks really clean, just letting you know.
Oh, thank you. Let's, for the sake of making this look nice, assume that it's going to continue outward into the rightmost direction. So it hit once, twice, So if I was drawing this to scale, it would come back up to the 5/6 of the height, then come back down. I've now hit the ground twice. 3 times. 4 times. 5 times. 6 times. 7 times. And finally, 8 times right there. There is my picture of what happened. Roughly. I mean, I could probably make a program that would do this much better and make a cooler path. So there's the first bounce, second bounce, third bounce, fourth, fifth, sixth, seventh, and eighth. What we need to do is count up all of the distance. If I could somehow take a tape measure and measure all of these curved distances, that would be my answer. The problem is calculating curved things is hard. I mean, that's why we created calculus. Calculus calculates curved things really easily. But we don't care about, we're assuming that he's dropping it straight up and down. It's not moving in the x or in the positive x or negative x direction. It's just going straight up and down, so we don't have to worry about that condition. So there's no curves. It's just a straight line going up and down. How are we going to do that? And the answer is somehow we're using this formula. We're going to have to modify it a little bit. Are we ready? All right, so what was my, let's just calculate this first value. This first value, this height here is what? This first height is what? Somewhere in this problem.
Oh, it's what about? Okay. Wait, what did you just say?
It's the 55 meter.
55 meters. So this, on this first bounce, we bounced 55 meters. I'm going to leave off units until the very end because that's what all mathematicians do. We don't really like units, although they do help you solve problems, especially in physics. So 55. And then I'm going to add that to the next bounce. Here's the trick, though. On this second bounce, this arc right here that I'm talking about, on this second bounce, I not only come up, but also down. So I'm going to have to multiply it by 2.
Wait, why?
So it not only comes up this same height, but it comes down this same height. So this second height that I'm about to find, I'm going to have to multiply it by 2. So plus 2 times whatever that height is. What is that height, by the way? And you can leave your answer with 5/6 in it. It's 2 times 5/6 of the previous height. How do I say that in math?
66.
Close. 2 times 5/6 of 55. This altogether is the second bounce. This was the first bounce. So this was the first bounce. This was the second bounce. Now I'm going to add the third bounce. So help me with the third bounce. I'm talking about this bounce right here. This is the second bounce. This is the
Third.
So yeah, this is gonna be the third time. So what is my number? What are my numbers gonna look like?
3 times 5 over 6.
Why did we do 2?
Because that was the second. Oh, wait, no, wouldn't it be 4?
It would not be 4. We just did 2 because it went up and down.
Yeah. So you times it by 2 again.
2 again. Yep. 2 times.
Yeah.
And now I need to do 5/6 of the 5/6 of the 55.
So wouldn't it be 4 6?
That's not exactly how fractions work. You just say 5/6 again. So if I have x again, it's x squared. So 5/6 again is 5/6 times 5/6 is 5/6.
Yeah, it's 5 6. Oh, to the power second.
Yes, to the power of 2 times 55. All right, and that's the third bounce. And then notice that on the 8th bounce right here, so we're going to do plus dot dot dot. For the 8th bounce, it's going to be 2 times 5/6 to what power times 55?
To the n?
We actually know what the nth is.
Oh, 8.
Should it be 8, 7, 6, or 9?
8. Wait. 7.
Daisy, what do you think?
What?
What power should it be? Notice that for the second term, it was the power of 1. Notice for the third term, it was to the power of 2. This is the 8th term. So it should be to the power of,
Oh,
it is indeed 7. Yep. And that will represent the 8th bounce. So second bounce ends, third bounce, perfect. So what we need to do is we need to use our formula right here. This formula, the first term times all of this stuff. How are we going to do that? This is the hardest part, I think. Drawing a picture and writing out the general formula isn't too hard. It can be tricky, definitely, but I think the hardest part is actually using the formula. I should mention this too. So our formula is, if I want to factor out this 2, I can leave that 2 at the very end. Let's go ahead and find the formula for this, then this, then this, and we'll do the 2's at the very end. So how do I just do a formula that goes 5/6 of 55, 5/6 squared of 55, 5/6 to the 7th of 55? Don't worry about this first term. This first term we're going to do at the very end also. Let's just focus right now on this, this, all of that. How are we going to do that? What is the first term? That's what my formula needs. I need a first term. What is my first term? Again, it's not this one anymore. It should be this one. So my first term, someone just read it off. Literally read me those 2 numbers.
2 times.
We're not going to do the 2 yet. We're going to do that at the very end.
Oh, 5, 6
Yep, so it's going to be 5/6
times 55.
times 55. That was our first term. Can't write 5s. That was our first term. So I'm just rewriting this formula now. I just wrote my first term. Now I'm going to keep rewriting the rest of the formula. 1 minus r to the n. This is going to be times 1 minus r to the n. Well, what is r?
R is 2.
Take another guess.
Um,
What am I multiplying by each time? My common ratio.
oh, 55.
Not 55 was my starting distance. So it's somewhere in this problem. You've used 2, you've used 55, it's the other number.
4, 6.
5/6, yes. So the 5/6 is the common ratio. That's the thing I multiply by each time. I'm always 5/6 the previous height. All of that to the power of n. And then all of this divided by 1 minus 5/6. All right, let's take a step back. Bigger picture here. What is this? What did I just do in terms of this problem? How do I relate the green to the blue? What did I just do? How do I relate the green to blue? What did I just find? What is this? It's not the whole problem, because I didn't add the
Is that
original.
what the 8th term is?
The formula?
It's the formula for what? Did I include the 2's? Did I include the second term? Did I include the third term? Did I include the first term?
Just the second term.
Second term, and then everything after that to the nth term. It's not including the 55, and it's not including the 2. We can nod our heads, we're following. We didn't include the 2, we didn't include the 55. Well, what should n be? How many terms do I actually have now that I'm not counting the first term?
7.
7. So I'm going to come back here and change this n to a 7. What we have just found is everything over here, but we forgot to multiply by 2. Let's do that now. If I multiply all of these by 2, I can just do that out here. Now I'm going to multiply by 2. I'll just do that right here. Times 2. And then finally, what is the last thing that I'm missing?
Plus 55.
Plus 55. This is the hardest problem that you'll see on the homework. And it is hard. It messes me up like every year that I teach it. I hope I'm teaching it right. I'm always nervous when I teach it because I frequently mess it up because it's so hard. Let's pull up our calculator. Let's go to, I'm going to use this calculator. I would recommend not using your phones because this one is so much easier. By the way, this is just desmos.com/scientific. So I'm going to do, in parentheses, 5, 6.
Times 55. Times 1.
5 times 1
Minus 5/6 to the power of 7.
that thing to the power of 7 divided by 1 minus 5.
Yeah.
There it is. There is our answer. That is how far the ball has
I
traveled.
forgot multiply by 2 plus 55.
Oh.
Divided by 2 plus 55. Thank you. I should have double checked that also. Looks good. All right. That is how far the ball has traveled. It has traveled 451.5 if I'm rounding to the nearest one decimal place. What is my unit? 451.5. It is, yep. Say it out louder.
Meters.
Meters, yep. So you can just say M. Whew, that was a hard word problem. It's kind of cool too. So that means that ball has traveled that distance. And again, that's just assuming it's going straight up and down, not bouncing out like that. Otherwise, we'd have to add that horizontal distance as well. All right, Daisy and Rochelle, you have your own example. Daisy, you get to read this one.
Daisy and Rochelle decided to invest their money in the stock market, where the average return of 0.6% on the last day of each month. Together, they invest $120 on the first month, and they keep investing $120 on the first day of each month after that. What would Daisy and Rochelle's investment would be worth at the end of the 5th month, round to the nearest cent?
Okay, yeah, so this is a real life example. Let's pretend that you're actually going to go in on the stock market. Maybe each share is $120 and it does have a 0.6 return on investment. How much do you think you're going to get? Take a guess. 0.6% isn't that much, but you are always adding $120 every 5 months. So at the minimum, you should have 5 times 120. So you're at least having $600, but with a 0.6% return each month. Take a guess. How much money do you have at the end of that 5th month? So 5 times 120 is 600. You're both going in on the stock market together. How much is going to be in your joint bank account? It's not that much more than 600. So guess between 600 and 650.
600, 650?
What's your guess for the answer for this example?
What's 6 and 6?
It's 36.
Okay, got it.
Daisy, Rochelle, take a guess. No, we don't. Want to take a guess?
I wouldn't know.
Okay. Let's go ahead and see how to do this problem.
Wait.
You can't do the math. You're supposed to be guessing, Rochelle.
$36. Just kidding.
So $636?
Yeah.
All right, we'll see if that's right. So this is what's going to happen. Let's look at the first month. On the first month, how much money do you have in your bank account?
120.
And then the interest applies after the last day. So now it's the last day. Now interest has been applied, and you're going to add $120 more dollars. So that was the first month. This was first month. On the second month, how much are you going to have? Now I have to apply the interest to $120. So how do I do that? How do I apply 0.6% interest on $120?
Would it be 1 plus 120 times by 0.6%?
You're really, really close. Yeah, so you multiply them. What are you going to multiply by 120? That's the question. So you add 100% to the 6%. So you're going to, on average, so you always do 100% plus or minus the rate. If you're going to be adding money, you add that to the rate. If you're going to be losing money because you're, I don't know, losing money for whatever reason, maybe from inflation, you subtract the rate.
Also, for this one, wouldn't it be subtraction? Because you're returning. You're on the last day.
They're giving you money, so you're adding money to your account.
They're giving, so it's adding.
Yeah. Banks account don't take, I mean, they do kind of take away money if you look through the eyes of inflation, but generally speaking, they do give you money by 0.6% if you're in the stock market in this case, I guess.
That's 1.06.
It is 1.06. Careful. 1.06 would be 6% interest, but it's 0.6% interest.
Oh, it's 1.006.
Yeah, there it is. 1.006 times $120. this function applies a 6% interest to $120. It's not that much. 1.006 times $120. That means you now have $120.72. So you only got 72 cents after the first month.
Great.
Hey, it's a stock market. That's an excellent return. That is slightly above inflation. All right. But not only did you do that, you also added another $120 in, right?
So for the next one, wouldn't it be 1.006 to the power of sec 2 times by 120? What?
So 1 second. So this is the second month. Say it again, Rochelle.
So for the third month, wouldn't it be 120 times by 1.006 to the power of the second?
So you do 1.006. I heard that part right.
To the power of the second.
To the power of second times
120
20
plus 120.
plus 120. Is that right? I'm trying to think. The trouble is you're applying the interest to the interest gets applied to 120, but you also, it's a little bit off. So it's 1.006 times 120 plus 120. So that's how much you had from the last amount. Would you agree that these two are the same amount? Now if I want to apply the interest again, now I need to multiply that entire amount by 1.006. What just happened? 1.006. And then on top of that, add 120.
This is for the third term?
That is for the third month.
Or third?
So the pattern here is a little bit harder to find, but once we find the pattern, the formula becomes really easy. The formula is a lot easier than bouncing a ball. All right. How are we doing? Give me a fist of 5. How well have we been following so far? You can be honest. 3? Michelle?
I'd say 3.5.
3.5? Okay. Do you want me to re-explain what we've been doing so far? Would that help?
I understand how, like, the whole, 1.006 times 120 plus 120. But it's just that, why don't you just add to the power of 2 on the third term?
That is essentially what you're doing. I just want to make sure that we understand how the problem relates to that. So you are correct in thinking that you're going to be multiplying 1.006 again, because 1.006 times 1.006 is 1.006 squared.
Oh my god, that's a lot. Because, honestly, it's better to do the exponents because it just shows that, we're doing it twice.
Okay, so you want to kind of skip the conceptual understanding and just skip to the formula?
Yeah.
Okay, that's fair. So our formula is 1.006 to the power of n, and in this case, n is going to be what? How many months were we doing this for? 5. So this thing to the power of 5 times our principal times our initial amount, which was 120. There it is. I guess I can do that in the reverse order if it matches the formula up above. So times 120 on that side. Doesn't really matter. Oops. I want to grab all of that. Yeah, what is that? 1.006 power of 5 and times 120. And there is, wait a sec. That is because we're not using our formula. Our formula needs to be 1 minus all of that. All right. 120 times 1 minus 1.006, all of this to the power of 5 divided by 1 minus 1.006. All right, now we go to the calculator. So we have, I'm going to do 120 times, whoa,
To
minus,
make it faster, why don't you just plug it into the other one?
because I wanted the other answer there just in case we needed it for whatever reason. All that divided by 1 minus 1.006, and you get $607. So it's definitely above $600. We didn't go up by that much, but you did gain $7 by just placing your money smartly. Someone gave you almost minimum wage for doing nothing aside from keeping your money in the right place. So 7.24 equals 607.24. Our units are money. There are other types of problems too. I think those were the two hardest ones that you now have in your notes. That homework is going to be due tomorrow. I know, Rochelle, you already took a crack at it and you didn't do so great, but if you could try again, that would be awesome. Get higher than 25%. Yeah?
Oh, I got 25%. No.
No? You got higher? Oh, I apologize then. What did we get? Oh, we didn't even... Whoa, you got 75. Dang!
I didn't do it because it wasn't
Nice.
even due until tomorrow.
That is true. Yeah, I apologize, Rochelle. I thought it was lower. I guess I was confusing daisies.
I actually thought that I didn't do the